You know, it feels like every few months a new headline pops up, warning us about some giant asteroid on a collision course with Earth. So today, we're going to dig into the latest one that's been getting all the attention, and we're going to separate the scary clickbait from the actual science. Okay, so there's this asteroid, 2024 yr4, and it has a non-zero chance of hitting Earth in 2032. And the question everyone's asking is, should you actually panic? Let's get into it. I mean, look at this. On one hand, you've got these wild headlines, right? Talking about its massive size, total destruction. But then, on the other hand, you've got the scientists who are, pretty calmly saying there's like a 98% chance it's just going to fly right by us. That gap between the hype and the reality, that's what we're going to close today.
All right, so let's properly introduce the rock at the center of all this chatter.
Okay, so this is it. Asteroid 2024 yr4. It was just discovered late in 2024, and right now, its size is a bit of a guess, somewhere between 50 and 100 meters. Now that's a huge range, right? And that's exactly why astronomers are pointing our biggest and best tools, like the James Webb Space Telescope, at it. They're trying to nail down a much more precise size.
Okay, before we even talk about the odds, let's get into the scary part, the big what if. Because to really get a handle on the risk, we have to imagine what would actually happen if it did hit.
See, the thing is, these rocks are moving at just mind-boggling speeds. We're talking up to 50 kilometers a second. And because of that, the hole they punch in the ground is way bigger than the object itself. A good rule of thumb is about 10 to 20 times the size of the asteroid. So yeah, a 100-meter rock could blast out a crater that's 1 to 2 kilometers wide.
And that's where the scale of this gets, well, kind of terrifying. A 2-kilometer crater is nearly a mile across. Imagine something deep enough to completely swallow a 60-story skyscraper. If that hit a populated area, yeah, it would be an absolutely devastating local catastrophe.
So what about the energy? We're talking about a release of something like 8 to 10 megatons. That's the same as 10 million tons of TNT. I mean, that's up there with some of the most powerful nuclear bombs ever tested. But, and this is a really important but, it is not a civilization-ending event. And that brings us to the key takeaway, and this comes straight from the people who study this stuff. The damage would be huge on a local level, for sure. But this is not the dinosaur killer. Civilization isn't going to end, so we can all just chill on that.
Okay, so we've talked about the boom. We get it, it's big, but what are the actual real-world odds of any of that happening?
All right, here's the number. As of right now, the best estimate for an impact is somewhere between 1 and 2%. Now let's flip that around. That means there's a 98 to 99% chance it's going to miss us completely.
So why are the odds of a hit so incredibly low? Well, you have to remember just how mind-bogglingly empty space is. Our brains are just not wired for it. We see these textbook pictures where the Earth and Moon look like they're practically next-door neighbors. But that picture? It's totally, completely wrong. Let me put it this way. If the Earth was the size of your hand, the Moon wouldn't be a few inches away. It would be over 30 feet away. And the most likely path for this asteroid has it flying by us at about that same crazy distance. So when you hear near miss in astronomy, it doesn't mean buzzing the tower. It means it's still incredibly far away.
So, you might be asking, where does that 1 to 2% chance even come from? Well, it all comes down to what scientists call a cone of uncertainty. It's basically the wiggle room in their predictions. If it did hit, we don't know the exact spot yet, but we know it would be somewhere along this very long, very thin path stretching right across the globe.
Okay, so you've got this tiny probability of a really bad day. How does scientists talk about that without everyone freaking out? Well, they actually have a tool designed for exactly this situation.
It's called the Torino scale. It's actually a really clever system, a simple 0 to 10 rating that combines two critical pieces of information, the odds of an impact and the sheer destructive power it's packing.
And to make it super clear, it's all color-coded. 0 is green or white. That's no hazard. Pretty much every asteroid we know of is a 0. Then you've got yellow, for things that merit attention from astronomers. Orange means threatening. And red? Well, red, levels 8 to 10, means a collision is a sure thing.
So the big question, where does 2024 yr4 fall on this scale? Right now, it's a 3. That puts it smack in the middle of that yellow zone. It's interesting for sure. It's something we need to keep watching. But it is not, I repeat, not in the threatening category yet.
And that's exactly the attitude the scientific community has. This quote just nails it perfectly.
It's not about being worried or panicking. It's just a signal to the pros to say, okay, let's get more data.
So, what happens next? What do we do between now and 2032 when this thing flies by? Well, the work is already happening.
This is super important to get. That 1 to 2% number isn't going to stay that way forever. When an asteroid is first spotted, our idea of its path is kind of fuzzy, right? But with every single new observation, that path gets sharper and more precise. And eventually, all that uncertainty just disappears. The probability will drop to 0, a confirmed miss, or it'll go to 100%. There's no in-between in the long run.
And you know what? We're not just sitting around waiting to see what happens. Humanity is actually getting ready. NASA's DART mission was a huge deal. It proved we can literally push an asteroid off course. And it's not just NASA. Countries like China are setting up their own planetary defense offices. We're actually starting to work together on this as a planet for the first time in history.
You know, it all really boils down to this simple but powerful advice from the astronomers doing the hard work. Just keep looking up. Because at the end of the day, the story of this asteroid isn't really about fear. It's about a global team of scientists working together, turning what if into we know. So maybe instead of being scared of the skies, the real question we should be asking is, what incredible things can we discover if we just remember to look up?